Alright, so we have talked about the unit circle before, yes? So we should be a little bit familiar with it, but we're going to talk about where everything comes from. Have you done that before? Maybe. So that's where we're going today. So it talks a little bit about like how we do that. Terminal points is just for an angle in standard position, it's where it ends. So if you heard that phrase, that's what we're talking about. For your reference angle, it's always the smallest angle that you can make from a terminal side of an angle in the x-axis. It's got to be less than 90 degrees or less than like pi over 2 radians. There should be a division bar there. So like if we had an angle that was bigger than 90 degrees, so let's say that we had like 135 degrees as our angle. So we went around 135 degrees. Your reference angle would have to be that smaller angle right here of 45. 45 degrees. So that's what that means. So even though like theta was 135, your reference angle would have to be 45. So that's that. Somebody earlier said SOHCAHTOA. SOHCAHTOA, that's all this stuff, yes. So we know that sine, cosine, and tangent, right? Have we talked about cosecant, secant, and cotangent before? It's the same thing as like cosine or sine, cosine, and tangent. It's just like the reciprocal, so you just flip it. So like sine and cosecant go together, cosine and secant go together, and then tangent and cotangent go together. If you look on your calculators and like pull up the trig menu, it kind of has the ones that go together in like the same order. So it has like sine, cosine, tangent, and then cosecant, secant, cotangent. So like it goes in order with the ones that are like inverses. Does that make any sense? I don't know if you understand what I'm saying, but that's how I keep them straight. Yeah, that's that. So we are going to build the unit circle using some of those things. So you can use special right triangles to build the unit circle. So that's what we're going to do. So I have like what your 45, 45, 90 triangle is supposed to look like and what your 30, 60, 90 triangle is supposed to look like. For both of these, our radius is going to be what? On the unit circle. What's your radius? Always 1, right? So the side that's your radius is your hypotenuse for both of these. So that means that like we're going to come over here, and so this is supposed to equal 1. So then we'd have to like solve and see what x is, and that would be our other two sides. Does that make any sense? Did you get what I'm saying? Yes, no, maybe. So we're going to say x square root 2 equals 1. Solve for x. What do you get? 1 over square root 2. Yeah? Do we have anything that looks like that on the unit circle? No, they don't keep square roots in the denominator, right? So what do we need to do with that? Fix it. It's called rationalize it. So you multiply by square root 2 over square root 2. So you're just multiplying by the denominator to get rid of that square root down there. So it's going to be square root 2 over 2. And that's something that we've seen on the unit circle before, right? Yes. So that would be like these sides. Square root 2 over 2, square root 2 over 2. So then if we've got like an angle on our unit circle that's like 45 degrees right here, and the point is out there, then we know that the coordinate is going to be like square root 2, square root 2, square root 2 over 2, square root 2 over 2, because that would be like this side and this side. Does that make sense? Yes, no, maybe. So that's where that comes from. So we'll do the same idea for your 30, 60, 90 triangles. So that's going to be for your other angles. So again, your hypotenuse is like your radius. So that was still going to be 1. So if we solve for x there, we're going to get that x is 1/2. So then this side is just going to be 1/2. And then what would this side be? Square root 3 over 2. So then again, that's going to make your coordinates. So we can do the 30-degree one first. So if you've got that 30-degree angle, the short side is going to be 1/2, and then the 60-degree angle is going to be your square root 3 over 2. So that makes your ordered pair there, square root 3 over 2, 1/2. Does that make sense? And so then if we flip that triangle and put the 60-degree angle down here, It's just going to flip your ordered pair. Do we need to see that? So, we're going to have the 60-degree angle down there, the 30-degree angle. So we'll have 1/2 on this side. Your square root 3 would be over here now. And that makes your ordered pair 1/2, and then square root 3 over 2. I'm running into the circle there. So that, again, that's where everything comes from that's on your unit circle. And then it just repeats over and over. So yeah, that's that. Do you have any questions right now? You're not going to have to like do that or prove it or anything. So that's just so you know where it comes from. I want us to go ahead and label a few things on the unit circle. We should know like what these 4 points are, because it's just like the point. If you go over 1 and then up nothing, what point is that? 1, 0, right? Is that okay? So that's one of them we got down. What angle measure is that? 0. So it's 0 in degrees. Does it change for radians? No, so it's still like 0 there. If we go up here, what point would it be up here? 0, 1. And what's our angle measure there? 90, so 90 degrees. And from the bell ringer, we talked about what that was in radians. What is it? Pi over 2. What about this point over here? -1, 0. And then if we went halfway around the circle, how many degrees is that? 180. And in radians, what would that be? Just pi. The bottom point down here, what would that be? 0, -1. And then, so we went 3/4 the way around the circle. What is that in degrees? 270 is kind of like 180 plus 90. So 270 degrees. And then in radians, what is it? 3 pi over 2. And then if we go all the way around the circle, how far is that in degrees? 360. And then in radians, 2 pi. Are we okay with all that? Those are the easy ones, right? All right. So we're going to take our 45-45 triangles, and we're going to put those here and get those reference angles, or those numbers. So we could like drop a line here, and that's making like our 45-45-90 triangle. Does that make sense? So it's like the one that we did before. And where did we say that's what was going to happen? Square root 2 over 2 and square root 2 over 2. So that's what this point would be here. Square root 2 over 2, and then square root 2 over 2 again. And it's at 45 degrees, right? Because it's a 45-45-90 triangle. And what is 45 degrees in radians? Right before, again, we did that in the bell ringer. So when we move that triangle over into quadrant 2, is anything going to change? Just your signs, right? That's it. So if we're looking in the first quadrant, it's like positive, positive. In the second quadrant, what is it? Negative, positive. So we're going to have negative square root 2 over 2, and then positive square root 2 over 2. What angle would that be? So we know that it's like 90 plus 45, so 135. And what is that in radians? It'd be like pi over 2 plus pi over 4, right? Because like we went this way, it's pi over 4, so that's the same again, but it's like pi over 2 plus pi over 4. So 3 pi over 4. You can just convert that also. So like multiply by pi over 180, and that'll get you there too. If we move that triangle down into the third quadrant, what's going to change now? Our signs, they're both going to be negative now. So we'll have negative square root 2 over 2, negative square root 2 over 2. And then if we add, it's 180 plus 45, so that's going to put us at 225. And when you convert that to radians, you get 5 pi over 4. And then if we were in quadrant 4, what are our signs going to be now? Positive, negative. So we'll have positive square root 2 over 2, negative square root 2 over 2. And that's 315 degrees. When you convert that to radians, you get 7 pi over 4. Questions on any of those? You okay with that? Is it making a little bit of sense? Okay, so then the next part, we're going to be using our 30, 60, 90 triangles on this one. So like we did on the other side. So for this one, our point, this was like our 30, 60, 90, so that was this triangle that we did. So it was square root 3 over 2 and then 1/2 on the bottom. So that's going to be the first part. So we can see everything. Square root 3 over 2, 1/2. And that was at 30 degrees. And what is 30 degrees in radians? Pi over 6. And then if we're looking at this triangle now, it's just going to switch, right? Because it's our 60-degree angle instead of the 30-degree angle. So it's just 1/2 square root 3 over 2. And we said that was 60 degrees, and in radians, what is 60 degrees? Pi over 3. We okay so far? Alright, so we'll keep working around the circle here. So if we're looking at this triangle, that's going to be like this triangle, so it just changes sides, right? So your x is now negative, so we'll have negative 1/2 square root 3 over 2. And if we're looking at, oh, we need to do our angle there real quick. So that's going to be at 120 degrees. Is that correct? Yeah. So 120 degrees. And then in radians, that's what? Anybody know? It's, what is it, 2 pi over 3? So again, if you don't have those conversions memorized yet from like that table that was at the bottom of your notes yesterday, that's a good way to memorize them there. Or you can just convert it like we were doing in the bell ringer, so multiplying by pi over 180 or 180 over pi, just depending which way you need to go. And then for this triangle, that's like the 30 triangle over here. So again, we're just going to switch the x and y because it's on this side now. And or no, we're not switching x and y. I lied. We're making the x negative. So negative square root 3 over 2, 1/2. And the angle there is now 150. And in radians, that's 5 pi over 6. This 1/2? It is. It just kind of ran into my fraction bar. Yeah, sorry. I can make that look better. Negative 1/2. Is that okay? Yeah. So then going into the third quadrant, our first triangle is going to be like your 30-degree triangle again. So we'll have that square root 3 over 2 and then 1/2. But x's and y's are both negative now because you're in that third quadrant. So negative square root 3 over 2 negative 1/2. And that's at 210 degrees. And in radians, it's 7 pi over 6. And then for this triangle, it's like our 60-degree triangle again. So again, your x and y are negative, so we'll have negative 1/2, and then negative square root 3 over 2. In degrees, it's 240 degrees. And then in radians, it's 4 pi over 3. And then when we do our fourth quadrant, it's only the y's that are going to be negative now. So that first triangle is like our 60 triangle again. So we'll have 1/2, then negative square root 3 over 2. And that's at 300 degrees. And that's 5 pi over 3 in radians. And then our last triangle is the 30 triangle again. So that's going to be square root 3 over 2, then negative 1/2. And it's 330 degrees, or 11 pi over 6. So the bottom part of this page is for you to put all of that stuff together in one place. I don't feel like I need to talk you through that, so I'm going to let you do that on your own. Is that okay? Yeah. Can we do that later and then move on to the rest for now? Yeah. So just take everything that we've already did and then fill it in here. So you're putting the 3 that we did all together on one. That's all. Is that okay? Alright. So I know that there's like some helpful tricks to help you memorize this stuff. So do y'all know of any of those right now? So Taylor and I were talking this morning, and she said she knows one that it's like the 3's are always on the, how did you say it? The 3's are on the top, the 6 is on the bottom.
Yeah, 3's are always closest to the first.
So 3's, 6's are there. And then when you're doing like your coordinates, you count, it's like 1, 2, 3, 1, 2, 3. When you're putting them all together. I don't know, maybe you'll see that when you're putting it on there. So this is what I'm talking about with that. I'm going to show you real quick. So we had square root 3 over 2, 1 over 2. We had square root 2 over 2, square root 2 over 2, 1 over 2, and square root 3 over 2. So it's kind of like you can do the square root of everything because the square root of 1 is still 1. It's like we go 1, 2, 3, 1, 2, 3, and then everything's over 2 still. So I don't know. I just do all that and you can do it. Sorry. So again, it's 1, 2, 3, 1, 2, 3. And that's going to work on all the sides. So that'll help you get that filled in. And then like the 4, we got those easy because it's just 0, 1, or 1, 0, 0, 1, negative 1, etc. So yeah, those are those. For your radian conversions, it divides your unit circle into 12, right? It's like 12 sections. 1, 2, 3, 4, 5, 6, 7, 8, until 12. So you can do, how is it? It's like pi over 6, or yeah, so like you can do pi over 6, and then 2 pi over 6, and then 3 pi over 6, and if you just reduce that each time, it'll get you the radians that you need, and that works all the way around. So 1 pi over 6, 2 pi over 6, 3 pi over 6, sorry, where is it? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So you can only do that on your 30, 60, 90s. But, yeah. I don't know if that's helpful. Or you can just convert it with the formulas we learned yesterday. So yeah, that's your unit circle. Are we all good with that? Okay, cool. So we'll move on to some other things today. So this is like a table that just pulls a lot of that information out. So I think it's kind of helpful, especially because you've got like cosecant, secant, and cotangent on there. So you don't have to think about what those are so much. You can just look at it. So I'm gonna cover this. And that's where you can see stuff. Okay, cool. So that's that. You can use that for reference if you need it. Yeah. So we're going to find the exact values of your 6 trig functions. So when we say the 6 trig functions, we mean sine, cosine, tangent, cosecant, secant, and cotangent. So it says let t be a real number, and p is your point on the unit circle that corresponds to t. So find the values of sine, cosine, tangent, cosecant, secant, and cotangent. So when we're talking about a point on the unit circle, it's sine and cosine, right? But which is x and which is y? So, like, this is a point on the unit circle, just like these guys were. So which is sine and which is cosine? X is cosine, and sine is y. So maybe let's write that. So any point on your unit circle is going to be like cosine sine. So cosine is your x and sine is your y. And I think of that like alphabetically. So cosine comes first, x comes first. So cosine and x go together. I don't know if that helps. That's how I remember it. So knowing that, it's super easy to find what sine is, right? So we could say sine of t is just your y value there, so what would it be? Square root 3 over 2. So then what would cosine be? Cosine is just our x value there, so negative 1/2. And then if we look back at the stuff that we had on the front page that tells you like what tangent is, we can figure out the rest from there. So what is tangent? Oh, it just is opposite over adjacent. Or like your y over your x. So for tangent, we'll do square root 3 over 2 over our x, which is negative 1/2. And then we'll just need to simplify that a little bit. So when you're dividing fractions, what are we really doing? Multiply by the reciprocal, right? So we've got square root 3 over 2 times negative 2 over 1. So your 2's cancel, and that's just negative square root 3. Okay? Yes, no, maybe. Okay. So then we're going to try to find cosecant. So like we were saying before, cosecant is just the reciprocal of sine. So if we already know that sine is square root 3 over 2, that means that cosecant is just going to be 2 over square root 3. So just flip that. Yeah? And we don't want to leave square roots in the denominator, so how are we going to rationalize that? Times square root 3. Alright, and then if we're finding secant, it's the same idea, but this time it's the reciprocal of cosine. So secant of t is just going to flip negative 1/2, so we'll have negative 2 over 1, or just negative 2. And the last one that we have is cotangent. So we already did all the work finding tangent, so we can just make that negative 1 over square root 3. But again, we don't want to leave your square roots in the denominator, so rationalize that. Multiply by square root 3 over square root 3. That's going to be negative square root 3 over 3. And that's it. Is that okay? Do you have any questions right now? Alright, so the next section wants you to do the same thing again with different angles, or do you want to say? Yeah. So we're looking at cosine of 5 pi over 4. So we've got to figure out where 5 pi over 4 is on your unit circle, and then figure out what cosine is from there. So if we had filled in our giant unit circle, we could just flip over at that and look at it real quick. We have 5 pi over 4 somewhere, correct? Yeah, right there. And we said that cosine, is that your x or your y? Your x, so it's just going to be negative square root 2 over 2. Yeah? So that is negative square root 2 over 2. So when it says it wants you to have an exact value, that's what it means. You could definitely type that in your calculator and get some like decimal answer for it. But if it wants an exact value, then you should be using like your unit circle to get there. Does that make sense? All right, so the next one is cosine of 8 pi over 3. And we should have that somewhere over here. 8 pi over 3. Where's it at? We don't have an 8 pi over 3. So we've got to figure out what that is. So, do y'all remember yesterday how we talked about coterminal angles? So like it goes around more than once and lands in the same place as something else. Talked about that briefly. So that's probably what's going on here as well. So let's find something close to it. We've got 5 pi over 3 here. So then we're trying to get to 8 pi over 3. Do you want to convert that to degrees and see where that falls? Would that be easier? Yeah? Okay, so 8 pi over 3 in degrees. What is it? $180 over 5. What do we get? 480. Is that correct? 480 degrees. So to figure out what that would be like on the unit circle, you could subtract 360, so it's 480 minus 360. 120? So if we go look at 120 on our unit circle, that's what we're talking about. Does that make sense? So like for me personally, I think that degrees are a lot easier to look at and find stuff than radians. But if you're good with radians, then you can leave it in radians. So again, we're going to 120 degrees. And what do we need, cosine? Is that correct? Yeah, so that's our x value again. So what's it going to be? Negative 1/2. Questions on that? Okay, cool. So, for number 4, we want to do tangent of 315. So 315 is going to fall on our unit circle, so we don't have to worry about finding another angle for that. So 315, where was it at? Right here. So tangent is what? Y over x, or like sine over cosine. So we'll have negative square root 2 over positive square root 2 over 2. What's that going to be? Negative what? And I'm going to write where that came from. So we had, was it positive over negative there, or negative over positive? Negative over positive. Negative square root 2 over 2 over square root 2 over 2. And then the last one we've got there is cosecant of pi over 6. So again, pi over 6 is going to go on your unit circle. And cosecant is going to be the inverse of sine. So we'll find sine of pi over 6, then just flip it. So sine of pi over 6 is what? 1/2. And so then when you do the reciprocal of that, what do we get? 2. Is that okay? Questions on that? So we're okay right now? Okay. We're almost done. Alright, so what about sine of negative 60? How would we do that? Yeah, so you could do 360 minus 60, or you could just head around your unit circle backwards. So go backwards 60 degrees, that would be 30 degrees, 60 degrees is going to be right here at 300. Yeah? Does that make sense? And what were we looking for? I already forgot. Was it sine? Yeah, so that's going to be our y value there, so negative square root 3 over 2. Yeah? So negative square root 3 over 2. And the next one wants secant of 45. So what does secant go with? What is it the reciprocal of? secant is the reciprocal of cosine. So we need to find cosine at 45 degrees, and then we'll just do the reciprocal. So if we go to 45 degrees, what is your cosine? Square root 2 over 2. So we're going to flip that and do 2 over square root 2. But we don't want to have square roots in our denominator, so what do we need to do? Times square root 2. That's going to be 2 square root 2 over 2. The 2's cancel, and it's just square root 2. Is that okay? Questions there? So the next part that we're going into, it's just got two different trig functions at the same time. So like for number 8, we've got sine of 45 times cosine of 180. So you've got to find whatever sine of 45 is, then multiply it times whatever cosine of 180 is. So we'll do that. Sine of 45, what is it? And that's your y value at 45. So square root 2 over 2. So square root 2 over 2 times, then we need cosine of 180. So that's your x value at 180. And what was that one? Negative 1. Negative 1. Is that okay? So that whole thing's just going to be negative square root 2 over 2. Number 9 wants us to find tangent of pi over 4. So tangent of pi over 4, and what is that going to be? Y over x, that's going to be 1. So 1 minus sine of 3 pi over 2. So that's our y value at 3 pi over 2. So 3 pi over 2 is like down here. And so your y value is negative 1, right? So 1 minus negative 1, what do we get? 2. Is that okay? Questions on that? Okay, so then we're going to look at secant of pi over 4. So secant of pi over 4. Again, so secant is your reciprocal of cosine. So we need to go to pi over 4 and then flip cosine. So pi over 4 is 45 degrees. Flipping cosine is going to be 2 over square root 2. We already did that up here, right? Because 45 and pi over 4 are the same thing. So can we just take this and pull it down? Is that okay? And not do all that work again? Okay, so that's going to be square root of 2 all squared, because it was secant of pi over 4 all squared. Then we're going to add cosecant of pi over 2. So cosecant is your reciprocal of sine. So we're going to pi over 2, and we need your y value. So pi over 2 is up here. The y value is going to be 1. So even when we flip that, what do you get? 1, because 1 over 1 is still 1, right? So yeah, square root 2 squared is just going to give you 2, and then 2 plus 1 gives us 3. 2 plus 1 gives us 3, so our final answer is 3. Is that okay? All right, cool. So the next section, you are going to use your calculator for those. I guess the only tricky part about this, you're just typing it in. But if it's in degrees here, you got to make sure your calculator's in degree mode. If it's in radians here, you got to make sure your calculator's in radian mode. What do y'all want to round to? 2 places, 3 places?
Yeah.
2, 3, 2. We'll go 2 places. And we know where to find all the trig functions on your calculator, correct? Nope? Okay, I need a calculator.
What did you say, 2 or 3?
2?
Okay.
Is that what we said? Yeah, 2. So all your trig functions are going to be under that button that says trig, it's out of 7. Did you find it, Taylor? So yeah, we'll do that.
Yeah.
All right, so we said we would round 2 decimal places. So for cosine of 48, what'd y'all get? 0.67? Yep. And then for cosecant of 21, what do we get? 2.79. Is that what you said? Yeah. And then for tangent of pi over 12, what did we get? 0.27. Is that okay? Questions on any of those? And you guys are lucky your calculators will do all the other trig functions. On old calculators, you had to like know the reciprocals and do like 1 over sine for cosecant and stuff. But you don't have to do that, so lucky for y'all. All right, and the last one there, we need to find the exact values of the 6 trig functions of an angle 4, -3 is a point on its terminal side in standard position. So that's just giving you like your cosine and your sine, and you've got to build the rest based on that. So like we did earlier. So ready to try this one? Yeah, okay, so cosine and sine. We know that sine is x or y. Which one?
Y.
Sine is y, so what is sine going to be in this one? What's the y value for the order pair that it gives you?
-3.
-3. And we know that cosine is your x value there, so what would cosine be? 4. And what is tangent? That's y over x, right? So -3 over 4. And then we're going to do cosecant, which is just the reciprocal of sine. So instead of -3, it's going to be -1 over 3. And then secant is just the reciprocal of cosine. So instead of 4, we'll have 1 over 4. And then cotangent is the reciprocal of tangent. So we'll have -4 over 3. And that's it. Is that okay? Do you have questions on anything?
No.
Okay, great.
Well, we'll practice.